Hello guys, welcome to this YouTube channel. So this time round, as we analyze the depth of mathematics in this new curriculum, we are going to start by looking at the different topics from Senior 1 to Senior 4. So today we are looking at number bases, and lesson 1 of it, we are going to look at how we deal with these numbers. So by the end of this lesson, you should be able to identify numbers in a base using the abacus. So when we are handling these lessons, we are going to look at them in 2 or 3 categories. The first is now understanding the mathematics behind a given topic. Understanding it is dealing with numbers. Then we shall bring the short scenarios as we progress to analyze the competence part of it. So this time round, we are saying that a base, these are numbers that are used, they are counting numbers, they are natural numbers, and they are just used to form a system. But these systems that are formed should always have numbers below the base. So when we say number bases, we are looking at two things: numbers that form a base, a limit. So you can have the numbers and the bases that are generated due to the numbers. So you can have the base. If we have base 2, the numbers that form that given base, we have 0 and 1. And sometimes this base is called a binary base. It's called a binary base because only 2 numbers form that base. Then we also have base 3. And the numbers that form base 3 have 0, 1, up to 2. 3 shouldn't be inclusive because numbers that form a base should be below that base. So we go to base 4. So we have numbers 1, 2, 3. Then now we go to base 5. The numbers that form it are 0, 1, 2, 3, 4. Then base 6. The numbers are 0, 1, 2, 3, 4, 5. And then we stop there. You can pause the video and tell me the numbers in the comment section that form this base. So we now have 0, 1, 2, 3, 4, 5, 6, 7, 8, and that is the end. Have you got it right? You can check. So base 10, we have the numbers that form it as 0, 1, 2, 3, up to 9. So these are the bases that we can state, but still they are infinite. You can go up to base 20, up to base 30, up to base 40, like that. So let's have a look at some of the examples of bases. Some of these examples of bases, when we are dealing with numbers, we can, let's say, form a number in base 5. To form a number in base 5, you can have 1, 4, and this is in base 5. 1, 4 is in base 5 because we said when you are forming a base, the numbers that we are using to form that base should be below that base. So we can also have 1, 0, 3 in base 8. When we look at this base 5, base 5 is here. And we look at the 2 numbers that are forming that number in base 5, and we take them, we have 1, and then we have 4 as well. It means that this number suits to be under base 5. In base 8, we also have it here, and we typically look at those numbers 1, 0, 3. These are the digits that are used to form the base 8, and still they are within that domain. So we can have so many examples of bases. We can also have the one in base 12. It can be 2, 5, 9, which is base 12. And the numbers that form base 12 stop on a digit, which is 11. So we can now analyze the applications of the real life occurrence of bases. So under the real life occurrence of bases, we can have the days of a week. The days of a week, they will never change. That's when we count Sunday, Monday, Tuesday, Wednesday, and those are the individual digits. The first day of the week, the second, the third, until the last. So these are 7 days. So this is the situation, and this is the base. We can have the pair of shoes. The days, the number of hours in a day. Hours in a day, they are 24 hours. They also never change. So sometimes the application of bases varies. Someone can decide maybe to generate heaps of tomatoes, heaps of onions. So depending on what they want, the heaps of tomatoes may be 5 in groups of 5, like that. So these bases can be altered depending on what someone wishes. So the next thing that we want to look at is representation of bases on an abacus. So as we proceed, we want to look at the representation of numbers on an abacus. An abacus is one of the tools that was used by the ancients back in the 17 and 1600s to add, to subtract, to multiply, and divide numbers in different bases. So this time round, an abacus, as we said, is a tool. It has grooves or rods and the counters. These counters are different. They are always, they vary from 1 to 9 in number. And when we are looking at an abacus, we can't forget to talk about the place values. So in actual sense, when you look at base 10, which is the standard base, it is the standard base, or some people can call it the decimal base. So when we analyze this, we can have this abacus. So we can have this. We can always put these are the rods, and on these rods normally there are some counters placed on it, like that. They vary in number, like that, like that. So we want to see how we deal with these place values. So if we are dealing with the base 10, we always start from the far right. This rod that is here on the far right indicates a place value which is 1s. Then here we have 10s. Then here we have hundreds. We have hundreds. Then here we have thousands. So as we proceed, as we go this side of the place values, we can have another one having 10,000, 100,000, and so on and so forth. So these counters that are always here determine the number that should be placed under. Now, like we have, these are the 3 counters here. These are 2 counters. These are 2 counters. These are also 2 counters. So in actual sense, it means that we are going to write this number as 2, 2, 2, then 3, base 10. So the number will be 2, 2, 2, then 3, and the base is 10. That's how we represent it. By this having a place value of 1s, this one goes to 10s, 100s, and thousands. So for any base that we have, we can now talk of base 5. Let's go to base 5. If we are talking about base 5, we can also have this abacus, like that. Still we have 1s. Then here we have instead of tens, we cannot have tens under base 5. So this time round we shall talk of 5. Then here we talk of 5 fives. Then as we proceed, we have 5 5 fives, like that. So in actual sense, this one, if at all we had 1 and here we had 2, in actual sense, the number would be 2, 0, because there is nothing here, there is no counter there. Here we have one counter, and the number will be 2 0 1 base 5, like that. So why we bring this, why we call it 5 fives? It means that when we are using two placeholders to unleash this number here will always be converted depending. This one goes to, we award it a 1, sorry, a 0, here 1, here 2, depending on the place values. So this shows that you have this 1 here, but this one here should not be multiplied by any 5. Then you have this 0 here, we multiply it with 1 5. Here we multiply it with 2 5s, which we are calling 5 5s. So as we change this, it is always a 2 times 5 times 5. That's why we are calling it 2 is in the place value, which we are saying 5 5s. Plus, then we have 0 times a 5. That's why we have the 5 there, the abacus. Plus 1 times 5 power 0. So here we are not multiplying by any 5, like that. So here it's the, we always do this to convert this base to base 10. But now we can also be given this, and we say represent it on an abacus. So it means that we are putting a 2, but it is in the placeholder where I have 5 5s. We are putting a 0 in a placeholder which has a 5, and we are putting a 1 at a point where we are not multiplying a 5. That's why we call it 1s. We are always multiplying by a 1. So what I want you to do as a student, I want you to try the one of base 4. I want you to try how we represent a base 3. I want you to try how we represent a base 2. Then you comment. For more information, go to the CATED app. There are a lot of materials. The notes are there. You can pass through them, and they are so detailed for you to understand as a student. So enjoy the CATED app with a lot of substantial matter in line with the new curriculum. I remain Agaba Ashraf. Thank you.